Hello everyone, my name is Horace, and in this video we're going to be going through LeetCode number 121, best time to buy and sell stock. For this problem, we're given an array prices where the index I in prices is the price of the given stock on the ith day. We want to maximize our profit by choosing a single day to buy one stock and choosing a different day to sell that stock. In the end, we want to return the maximum profit we can achieve from this transaction, and if we can't achieve any profit, then we want to return 0. So as always, let's go through an example so we understand the question more clearly. So this is the given example. The array prices is given as follows, and I've gone ahead and visualized it in a chart so you can see the different transactions that are possible throughout the days. Ideally for this problem, we want to buy the stock at the minimum price and sell it at its maximum price, bearing in mind that the maximum price is in the future. That's because, say we buy a stock on day 2, we cannot sell it on day 1, even though the profit would be 7 minus 1, which is 6. We have to find the maximum price following day 2. That means the maximum price after day 2 is on day 5. So the maximum profit in this case is 6 minus 1, so $5 of profit. So how are we going to keep track of when we're going to buy and sell these stocks? Well, we can use the 2 pointers technique to keep track of the left pointer and the right pointer. In the context of this problem, the left pointer is going to represent when we buy the stock, and the right pointer is going to indicate when we sell the stock. And we want to continue to move the pointers until the sell pointer is at the last element in the list. So let's go through an example with the 2 pointers technique. Since buying and selling a stock on the same day will yield a maximum profit of 0, we initialize the left pointer at the first day and the right pointer on the second day of the given prices. Next, we check the maximum profit that we can get. So in this case, if we buy at a price of 7 and sell at a price of 1, we're actually losing money. So we have minus $6. But remember from the problem, it said that if we cannot make any profits, we simply return 0. And since 0 is the maximum between 0 and -6, we still return 0. Remember that we want to purchase our stock at its minimum value. So that means if the right pointer is less than the left pointer, we're actually losing money on this transaction. So if we purchase a stock on the next day, we have more potential to make profit in the following days. That's because we're trying to reach the minimum value in the price history throughout the entire days. So what that's going to look like is that we're going to, on the next day, increment the right pointer and also move the left pointer because we saw that the next day price is less than the current day price. Then again, we check the price difference to see if we make any profits. In this case, we have a price of 5 minus 1, so we get a profit of 4. And we save this value since it's greater than 0, which was the default maximum profit if we cannot find a transaction that makes a profit. So now we increment the right pointer again, since it's the next day, and we check, is this transaction going to yield a maximum profit higher than the one we already calculated? Well, we can simply see that 3 minus 1 is 2, so we see that 2 is actually less than 4. That means we don't actually update the maximum profit since we found a transaction that yields a higher maximum profit. Then we continue to increment the right pointer, so we move the right pointer 1 over, and we again calculate the maximum profit that we can get. So we have 6 minus 1, which is 5, and 5 is greater than 4, so we update the maximum profit to be 5. And finally, we increment one last time until the end of the array, and we see that 4 minus 1 is 3, and 3 is less than 5. So in this case, we return 5 as our maximum profit that we can get purchasing a stock on one day and selling it on a different day in the future. So let's recap on the techniques that we use to solve this problem and develop the algorithm. First, we want to have 2 pointers. Then we want to increment the right pointer until the end of the list. We want to update the left pointer to be the right pointer if the left pointer is less than the right pointer. And finally, we want to check the maximum profit that we can get on that day. The time complexity for this algorithm is going to be big O of n, since we're traversing the entire array. Now that we have some intuition as to how we can solve this problem, we can go ahead and write the code for this algorithm. So writing the code, we can begin by initializing the left and the right pointers. As we said, the left and the right pointers are going to be on the first day and the second day respectively. We can also initialize the max profit at 0, and we also know that we're going to return max profits in the end. Then we can write the for loop until the right pointer reaches the end of the array, so while r is less than the length of the prices array, we want to just increment the right pointer by 1. But before we increment it, we want to check the max profits. So max profit, will update it between the max profit that we currently have, as well as the difference between the days that we buy and sell. So prices at index R minus prices at index L. And finally, we just need to update the left pointer if we find a price that's lower than what the current left pointer is at. So we can simply say if the prices at the right pointer is less than the prices at the left pointer, we'll update the left pointer to be the right pointer. And this is the entirety of the code, believe it or not, so we can submit it and you can see that the code is accepted. And with that being said, hopefully you learned something, and I'll see you soon.